We're back discussing some ideas about chances and probability. We have just a couple of selected topics to look at in our next section from chapter 14. And to help us get a good understanding of the terms, we're just looking at a couple of ideas, really the idea of mutually exclusive events, the addition rule, and then a couple of ways of thinking about distinguishing between when to use different probability rules. Mutually exclusive events are defined as events that are where the occurrence of one event prevents the occurrence of the other event. So they cannot both occur. I know some of you out there are in a criminal justice context. A great example of two mutually exclusive events is criminal sentencing in trials. Oftentimes, someone might be, we could look at the probability of certain charges. So a person for the same crime is not going to be charged with both murder and manslaughter. They are mutually exclusive. We would just look at the occurrence of the chance that at least one event occurs. So a criminal goes on trial. What's the chance that they're sentenced or to any of murder or manslaughter, let's say? If you want to find the chance that at least one event occurs, just what we're discussing, and the events are not mutually exclusive, which can happen, make sure you don't add the chances. The sum will be too big. And we're going to look at how this works in just a moment. But it's important to remember when to multiply and when to add. For more details on when to add, the addition rule is specifically for mutually exclusive events. So if you want to find the chance that at least one of two things will happen, first, check to make sure that the events under consideration are actually mutually exclusive. If they are, then you can go ahead and add the chances. For example, when a card is dealt off the top of a well-shuffled deck, there's 1 chance in 4 for it to be a heart. There's a 1 in 4 chance for it to be a spade. What is the chance for it to be in a major suit, as in hearts or spades? Well, that's going to be equal to the sum of each of these individual probabilities. It couldn't be both hearts and spades. It's just one card. It could be, we want to know the occurrence of the chance that one of these two mutually exclusive outcomes happens. So a heart, 1 in 4 chance, a spade also has a 1 in 4 chance, and we can sum their probabilities and there'd be a 1 in 2 chance of our first card dealt off the top of our deck being a heart or a spade. And we can check this mentally to make sure it works if we remember that there's 4 suits in the deck and half the cards in the deck total are hearts or spades. 1/4 of the deck each is one of these. So this makes sense. Let's look at a different example. So now someone throws a pair of dice. Let's think true or false. The chance of getting at least 1 ace is 1 out of 6 plus 1 out of 6. Well, in this case, we can't add the probabilities because these 2 dice are completely independent. And when we have, if you think about this logically, you can see that it makes sense because we need to separate these probabilities out. and examine them separately, you can see that there's 6 ways for a white dice to show 1, 6 ways for a black dice to show 1. Since they're independent and in no way mutually exclusive. The real issue here is that you could easily get a 1 with both of them or on either one. So the chance actually works out to be 11 out of 36, not 1/3. That's just too high. Don't worry, we're going to do some more problems in that area. But let's first think about what's the difference between a mutually exclusive and independent event. With mutually exclusive events, the occurrence of one prevents the other event occurring. You just can't have your first card be both a heart and a spade. It must be one or the other. It's an either or situation. You can't be charged with murder and manslaughter for the same crime. You get just one of them. Independent events, the occurrence of one event does not change the chances for the other event. In this case, the events, like a coin toss, are completely independent. And later on in our course, we'll look at some different ways of, in more complex scenarios, testing for independence of events. So we'll specifically have a test that'll tell us that we can use to ascertain if 2 events are independent in the context of a research study. Another important question is, when do I add and when do I multiply? First, to find the chance that at least one of 2 things happens. The events must be mutually exclusive, and you can just add the probabilities of the events. However, if you want to find the chance that 2 things both happen, they clearly can't be mutually exclusive. In this case, we would multiply the probabilities. And multiplying, there are 2 scenarios where you could multiply probabilities. They could be either conditional or unconditional. When you have unconditional probabilities, the 2 events need to be independent. If you have 2 independent events, you're going to use the unconditional probability. However, if you have dependent events, then you need the multiplication rule requires that you use the conditional probability for the events, because the second event occurring is dependent on the first event. So this is layering in some of the material from chapter 13, but this is a nice layout of when to add and multiply in probability problems. Remember that our applications of these, we're only going to look at pretty basic applications of probability and just this small portion of chapter 14. It's helpful when you're working out chances to sometimes map out some possible ways that the chances can turn out, and that might be helpful for you. We'll look at some strategies for approaching these problems in our next section, looking at the review exercises for chapter 14, just the selection of the exercises that we apply to our material.